Hello, my name is Roxy and I'm currently a third year maths student. So I'll be briefly discussing the project that I have completed throughout the summer, and it was based around calculating the hill radius of known hot Jupiters. I was supervised by Dr. Phil Sutton, who specialises in physics at the University of Lincoln and is also a part of the astrophysics team. Just a little bit of background information. Currently, there are over 4,000 confirmed exoplanets. However, until this day, there are no confirmed exomoons orbiting them. The issues come down to the detection methods and techniques used to identify them. This project aimed to focus around more of a mathematical approach rather than regular detection methods to identify possible candidates to host an exomoon. So moving on to the methodology, to start the process off, I had to extract the data from the NASA Exoplanet Archive, but before exporting it into an Excel file, I had to ensure I had the necessary properties needed to compute the calculations. So looking at the formula, we can see that it was essential for me to have the semi-major axes, the eccentricity, mass of the planet, as well as mass of the star in order for the calculations to be completed. The formula then approximates the Hill sphere of the exoplanet. The results maintained from those calculations have been exported from Excel to MATLAB. From there, I've been able to construct a plot that shows a clear distribution of the results, which allowed me to identify the exoplanets with the largest Hill sphere. So these are some of the results collected, and from the plots we can observe that most of the results are based on the left-hand side of the plot, meaning that the Hill spheres are just not as large as we would like them to be. For comparison, I have plotted planets from our solar system just to see if there are any exoplanets that may lie close by to those planets who have moons orbiting them in our solar system. For example, Jupiter, which has 79 moons, and Saturn with 82 moons. That substantial amount does come down to the distance from our Sun and the mass of the planet. Further observations have showed that there were some consistent outliers within the plots. So, for example, just right here, you've got one here as well as three here. Same on this plot, three here and one there, and one there and three here. After analysing it further and using the spreadsheet I have initially created, I have been able to identify those outliers and what planets they are, and they are listed just here. The Hill spheres were interestingly large, but further research would need to be conducted to see whether they have the right properties to host an exomoon. So, to conclude, the data did indeed show some promising results based on the calculated Hill spheres. However, further research needs to be conducted to clarify whether they would be the right candidates. To accommodate this idea, modelling the exoplanets listed on the previous slide using numerical solutions would be an ideal next step, as it would allow us to visualize the capture process of the moon and whether it can remain stable. Thank you for taking your time to listen to this presentation.